Yes.
Let's continue. Okay?
Yes.
I was saying maximum height is the greatest height attained by a projecting or by a projectile. Projectile what? Projectile body. Okay? So if they ask what's a projectile body, is a body which described a projectile path. That is 1. 2. The second term that we use, the second one. The second is what we call time taken, time to reach the maximum height. Let's look at time. Time taken to reach maximum what? Maximum height. This thing we have already discussed them sometimes back. You should know the only difference now because this one is projected at a given angle. So V, if this is equals to V, which is equals to Uy plus A what? AT. A what? AT. So we want to find the time taken to reach this maximum height. Time taken to reach maximum height. So from here, time taken to reach up to this point B. Okay? Sandra, are you seeing?
Yes.
Yes, we want to find that time. So how do we find that time? Which means at that point, the body is still moving upwards, not so? Which means the final velocity must also be what? We said at maximum height, at I max, V is equals to what? 0 meters per what?
0.
And A is equals to negative what?
Negative G.
Negative G. So if that is true, which means we are looking for this time. This is the time taken to reach the maximum height. So which means if I make T the subject, so I'll have V, T equals to V, not so?
Yes.
What it is going to be like what?
Minus U.
Check well. Okay, let's first leave it in terms of A. V minus U what? Uy, not so? Over what? Over A? Over A. Over A. But remember we said A is equals to negative G. Not so? So which means I'll have T equals to V minus Uy out of negative what?
G.
Negative G. So this negative will affect that. So which means our negative, we shall have Uy minus V over what? Not so? Have you seen that? Members, have you seen that?
No.
The negative, this negative will affect this because this one is the same as, we said a positive divided by a negative. What do we get? We get a negative, not so?
Yes.
Which means it will be V minus Uy out of what? Out of G. So when you take this negative inside, you find that you remain with Uy minus V. Not so?
Yes.
Good. So let's substitute. So our T is equals to, what's Uy? Uy is what? U sine.
U sine.
Sine theta minus what?
Minus
0 over what? Over G.
Over G.
So therefore, time taken to reach maximum height is given by U sine theta over what? Over what?
Over G.
Over G. As simple as that. Remember, always, if you cannot remember the formula, then know how to derive it. That's why I'm trying to take you through that. Okay? Yes. Always remember that. Let's go to number 3. Number 3. Number 3. Number 3, time of flight. That is what we call time of flight. Time of flight, and we use capital letter T. Time of flight. Time of flight, it refers to the total time taken. Is the total what? Time taken by the projectile to move from the point of projection to the point where it lands on the horizontal plane, through the point of projection, Sandra?
Yes, teacher.
Can you write this definition down? Is the time taken by the projectile to move from the point of projection to the point where it lands on the horizontal plane, where through the point of projection, through the point of.
I'm moving very fast.
Is on the screen. Are you not seeing the screen? The work is on the screen. You are using a
Hey.
phone. You are using a phone.
Yes.
Yeah. But it's even if you can still see the work, not so?
Yes, I'm seeing it.
Yes, put your phone in a landscape. Put your phone in landscape. Okay?
Yes.
So let's look at this. So back to our diagram, what we call the time of flight, the time taken to move from point O, which is the point of projection. This is point of projection. That is point of projection. Up to where it will land. It will land at point what? At point C. So the time taken to move from point O, B up to point C, that time is what we call time of what? Time of flight.
Time of flight.
But if you remember, when we are looking at vertical motion, vertically upward motion, we said for a body to move, because the sleeping is being affected by the same acceleration due to gravity. Okay? Which means time taken to come back from the point B is the same as the time taken to reach what? To get to the maximum height. Do you remember that? Yes, time taken to reach the maximum height will be the same time taken to from the maximum height to reach the what? To reach the ground. Okay? Yes. So in a nutshell, we can say, let's derive it. Let's derive it so that you can see. So which means this one is what? This one is under horizontal motion. Is under horizontal motion because it is said it must be horizontal plane. So but the body when it's moving is in a vertical plane. It is in a vertical what? In a vertical plane. So which means we must use for vertical motion. We must use for vertical motion. So which we said H will be equals to UT plus a half AT what? AT squared. But this time the body is moving upward. When is it describing? It's describing that path in the vertical what? Motion, which means this one should be what? UY. Now, when you look at when the body reaches this point of projection, when it reaches this point, what is there horizontal distance? Is there maximum height? Is there height at that point?
No.
Height at this point, height is what? 0. So at that point, so it implies that our height will be equals to 0 what? 0 meters. And our acceleration will be equals to negative what? G. And the time t will be equals to now capital what? Will be equals to capital T, which is the time of flight. Okay? Are you together? Members, are we together? So let's substitute. So it implies now our h equals to UTY plus a half AT squared. Now we shall have our h, which is 0. Okay? Our h, which is what? 0 equals to, what is our uy? Our uy is what? U sine what?
Sine.
Then we said t now will become capital T. Minus a half g t squared. Okay? So please, there's a lot of noise somewhere there. There's a lot of noise there. Good. Now, what do we do from here? What do we do? what do? You just factorize this, not so? You see t is common. So it's the same as saying u sine theta times t minus I have gt squared is equals to what? 0. So you see t is common, you factorize out t, so which means t into u sine what? Sine theta minus I have g what? T is equals to 0. So which means either t is equals to 0 or u sine theta minus I have gt is equals to 0. So t can never be equals to 0 at that point. At that point, time taken to cannot be 0. So which means which one are we taking? We are taking this one. Okay. So using u sine theta minus I have dt equals to 0. So let's make t the subject because we are looking for t. So which means we shall have gt over 2 equals to u sine theta. So it implies now gt is equals to 2u sine what? Sine theta. When you cross multiply here, when you cross multiply that, okay? So when you divide all through by g, you divide all through by g. So therefore, our t is equals to 2u sine theta over what? Over what? Over g. Have you seen that? You have seen that, eh? So in a nutshell, in a what? In a nutshell, time of flight. That's a time of flight. Time of flight is twice. Is twice the time taken. Is twice the time taken to reach maximum what? To reach maximum height. So you can just say t is equals to 2 what? T is equals to 2t. Where small t is equals to u sine theta over g. Members, are we together? Stephen? Sandra?
Yes, teacher.
Are we together on that?
Yes.
Yes. Take note of this. You should know how to derive this. Why I'm taking time to derive them. You should know how to derive them. Okay? And how we arrive to that point, because those are sometimes they ask for them. Number 4. Range. This is the horizontal distance. Is the horizontal distance from the point of projection to where the projectile lands along the horizontal plane through the point of projection. Through the point of what? Projection. So it's this one. So the distance from this point up to here, that distance is called what? That distance is called what? Range. From here up to that point. That distance is what we call our what? Our range. So it's a horizontal distance. How do we find that distance? The definition, you have seen it. You can write that. You said it is referred to horizontal. It is horizontal distance. Is horizontal distance is the horizontal distance from the point of projection to where the projectile lands along the horizontal plane through the point of projection. Now, members, the assumption made here. Assumption what? Assumption made. One, negligible, air resistance. Negligible what? Air what?
Resistance.
So which means we ignite, we neglect the what? The air resistance. We neglect the air what? Resistance. Because we know air resistance can affect the motion of a body, but this time when we are doing this calculation, we neglect what? The air resistance. Okay? Take note of that. Sometimes they may ask you state the assumption made in your calculation. State the assumption made in your what? Calculation.
Calculation.
Yes. Okay, let's see how do we find that. How do we find that? So since I've said is horizontal distance, which means we must use for horizontal motion. We must use for horizontal motion. Since the distance, which means we must use the second equation of what? Motion. So S equals to UT plus I have AT squared. AT what? Squared. Remember, this is horizontal motion. If it's horizontal motion, which means acceleration will be equals to 0 meters per what? Per second.
Per second.
Okay? What else? What else? Now, since we are describing the whole path, which means that time taken, that time t, will be the time of what? Will be the time of what?
The time of flight.
Of flight, because we are describing the whole motion from here up to here. From here up to here. And that time taken to move from here up to here is called the time of flight, which we have already derived it. So let's look at our substitution. Then our S will be our what? Will be the what? The range? The range R. So let's substitute. So it implies that R is equals to, so U what? UX times the time T, the times T, plus I have times 0 times T what? Times T squared. So you find that our R will be equals to UX, UXT. Okay? But what is UX? What is UX, members? If you remember, what is UX?
Equals of theta.
Time.
UX cos
Theta.
cos theta. Then T is what? 2 U sin theta over
Sin
what?
theta.
Over what?
G.
Over G. So when you substitute that, so it implies that our R is equals to U cos theta time 2 U sin theta over what? Over G. So when you combine that, therefore our R will be 2 U what? U what? U times U. It will become U squared. No, sir? Cos theta, sin what? Sin theta. Over what? Over G. There's something I've seen there. I don't know whether some of I've seen. Some of you have seen also. There's something I've seen in this formula here, which we can simplify it further. I'm seeing 2, then I'm seeing cos and sin are combined. Is that one not double angles? If you remember double angles.
Yes.
Recall.
Yes.
What? Recall.
Recall.
Sin what? 2 what? 2 theta is what? Is 2 cos theta.
2
Sin what?
cos theta, sin theta.
Sin theta, not so? So which means it implies now 2 cos theta sin theta must be equals to sin what? Sin 2 what?
Sin 2 theta.
If that is true, so which means now our R, it implies now our R will be equals to U squared sin what?
Sin 2 theta.
Over what?
Over G.
Over G. Okay? Members, have you seen that?
Yes.
Then there's what we call maximum range. Maximum what? Range. Number 5, maximum range. Maximum range. Maximum range. We said for maximum range to occur, for maximum range to occur, the angle of projection theta must be 45 degrees. The angle of projection must be 45 what? Must be 45 degrees. That one has been proven experimentally. So we are saying that for maximum range to occur, so for maximum range, let me just have a simple sketch here. For maximum range to occur, the angle of projection, the angle of what? Projection must be 45 degrees. Must be 45 degrees. So this angle here, the body must be projected at a speed that is u. So this angle must be 45 what? Must be 45 degrees. So this is our u sine theta. This is our u cos theta. So the distance here is what we refer to as range. Then this one will be R what? R max. Members, have you seen that? So let's see how we arrive to that point. So we are saying for maximum range, comma, the condition is, this is the condition for maximum range. Condition, sine 2 theta must be equals to 1. Sine 2 theta must be equals to 1. Sine 2 theta must be equals to what? 1. If that one is true, so now what is the angle theta now? Because we want to find the angle theta. So which means it implies that angle theta, we shall have 2 theta equals to the sine inverse of what? The sine inverse of what? Of 1. So which means 2 theta will be equals to what? What is the sine inverse of 1? What is the sine inverse of 1? Is 90 what?
90 degrees.
Yes. Which means if you divide by 2, which means theta is equals to what? 45 degrees. Now, if that one is true, what will be the formula for maximum range? The formula for maximum range now will be from R equals to u squared sine 2 theta divided by what? Divided by g. Remember we said for maximum range to occur, the sine 2 theta must be equals to what? Must be equals to 1. Must be equals to 1. And theta is now 45. So which means it's the same as saying R is equals to u squared sine of what? Sine of 2 theta out of g. So R max. So which means this one must be, but sine 2 theta must be equals to 1. So which means I'll have u squared over what? Over what? Members, have you seen that?
Yes.
Yes. So they may give in a statement. They said state the condition for maximum range to be attained. You just say the maximum range is attained when the angle of projection is what? 40 what? 45 degrees. Sandra, your background. Stephen.
Yes, teacher.
Have you seen it?
Yes.
Very good. That is a maximum range. That is maximum what? Maximum range. Now, subheading, equation of trajectory. Equation of trajectory. Let me give a simple sketch here. Let me give you a simple sketch here and then we proceed. We have this one here. This is our y. This is our x. This is the point of projection. This is B. I mean, let's say this is A, and then B. We have described them. Now, members, the path followed by this path followed by a projectile is what we call what? Trajectory. Okay. So when we talk of a trajectory is the path described by a projectile. Is the path described by a projectile what? Body. Is a path described by a projectile body. Now, when we talk of equation of trajectory, which means we are combining x and what? We are going to combine x and what? X and y components. We are going to combine x and y components. But remember, when we are talking about x, a trajectory is expressed in terms of horizontal distance and vertical distance. If you remember very well, what was our x? Our x was, if you remember very well, our x was u cos theta what? T. Not so?
Yes.
U. Then and y was equals to what? What was y? Y was u sine what? Sine theta t minus what? Minus a half dt squared. Do you remember that? So the equation of trajectory will be derived from these two concepts. So now this one is already, so shall have y equals to u sine theta t minus a half dt what? Squared. Now what I will do, so that because I want to express both of them in one equation, I want to express them in one what? In one equation. So which means I have to find a way of removing so that I have both x and y involved here. So, but how can I do it? So the only way I can do it, because this equation is simplified. So what I will do, I will use substitution method. Method. So I will say from x equals to u cos what? Theta t. How can I make x to enter here? Which means I have to remove this t. I'm going to make this equation in terms, I'm going to make t the subject from here. Okay? So if you make t the subject, what do you get? You find our t will be equals to, will be x over what? Over u cos what? U cos what? This is it. Let's call it star. Let's call it what? A star. Now what I will do, I will carry this equation, the star, I will put it in this one, because I want this one. This equation must combine the distance x, the horizontal distance x, and the vertical distance y. When you have all of them combined, that's one when we shall refer to as what? Equation of trajectory. Are you together? Now I will say, now it implies now y equals to u sine theta time my t, which is it? X over what? U cos what? Cos theta minus a half g into my t, which is x over u cos theta what? But what? But squared. Members, are we together?
Yes.
Good. So let's simplify that. This now, we have stopped physics. Now let's come to mathematics now. So we shall have y equals to, we shall have u, u sine theta what? Sine theta what? X over u cos what?
U cos
minus
theta.
a half g. So when you expand this one, what do you get? We get x squared, no sir? Over u squared cos squared what? Cos squared what?
Theta.
Cos squared theta. You see from here, you can see that u and u can cancel out, not so? U and u can cancel out. Now we have sine over cos. What is sine over cos?
tan theta.
That is tan. So which means our y will be equals to, let me say x tan what? Tan what?
Tan theta.
Tan theta minus I will have dx squared over 2u squared
2u square
cos squared
cos square theta.
Okay. Now, when you look at this one very well, let's say, therefore, our y is equals to x tan theta minus dx squared over 2u squared cos squared what? Theta. That's one equation. That is one what? That is also called, this is what we call equation of trajectory. This is what we call equation of what? Trajectory. But also, or if you recall, we said 1 out of cos. What is 1 out of cos, members? 1 out of cos is what?
Sec theta.
Is sec theta, which means it implies now 1 out of cos squared theta is going to be equals to what? Sec squared what?
Theta.
So which means our equation now will become y equals to x tan theta minus dx squared sec squared what? Sec squared over what? Over what?
Over 2.
Over 2u. Over 2u what?
2u squared.
Over 2u squared. That's also another equation. So this equation we have derived, you see now is combining x and what? X. This equation is what we call equation of trajectory. Is what we call equation of what? Trajectory. Any question? Any question? Members, any question?
Don't have.
Hmm?
Shall don't have.
It's clear, right?
Yes.
All right. So now, the only thing left is now calculations. Now what? Calculations. Be very careful with these formulas. They may ask you to derive them. They may ask you to what? To derive them. Yes. Now, before we go to calculation, before we go even to what? Calculation. I think this note here, the note here, the int. I think it. We say that if a particle is projected vertically upwards, the motion it described is purely kinematic, which is motion under gravity. Which means when a body is projected vertically upward, which means the angle projection is what? 90 degrees. That one we have seen it under equation of motion now, which we shall recall back. I think that. But if it's projected at an angle to the horizontal, if it's projected to an angle to horizontal, that motion it described is what we call projectile motion. It is projectile what? Motion. And that motion it described, that path is parabolic in nature, is a parabola. That motion is what? The curve it is. This curve you are seeing here. This curve is called what? A parabola.
Parabola.
That path is what? Parabola. So then we just call it parabolic motion. It's called what? Parabolic what? Motion, which means projectile motion. Sometimes that's how they trick you. They may trick you. They may say that, show that the path followed by a projectile motion is parabolic in nature. That's how they may set the equation. Okay? That's how they may set the what? The equation. Show that a body projected at an angle theta to the horizontal describe a parabolic path, or describe a parabola. They may just say is a parabola. So which means they are telling you to derive the what? To derive the what? Equation of trajectory. They are telling you to describe the what? To derive the equation of what? Trajectory. Are you together, members? Members, are we together?
Yes.
So we have only 5 minutes remaining. Exercise. Now you write for me this question. Question number 1 here. This question here. A particle is projected with a velocity of 30 meters per second at an angle of elevation of 30 degrees. Find the maximum height or the greatest height reached, time of the flight, then the velocity and direction of motion at a height of 4 meters. At a height of 4 meters on its way downwards. Members?
Yes.
The third question, I think the third question, the velocity and the direction they're asking for. Is this one we were talking about here? It was this one. It is this one. It is this one. Okay? I think that is this one. Because when it reaches the ground, at that point it has come to rest, which means at this point the final velocity must be what? At this point the final velocity must be 0 because the body is being brought to rest. Yes, but now they're asking you the velocity at the height of 4 meters above the ground on its way downwards. So which means they're telling you this distance here is for what? Is for what? Is 4 meters. So you do that calculation, which means you have to find Vx and find what? V what? Vy. Then use Pythagoras theorem to find V. Are we together? Members, have you written the question down?
Not
Yes,
yet.
teacher.
Okay, you finish. We have 4 minutes. We have 4 minutes remaining. Then another thing, as you copy the question, please, let's keep time. Let's keep what? Let's keep time. Yes, Stephen. Stephen, I'm seeing your hands up. Yes, Stephen? It was a mistake, eh?
Yes.
Okay. Members, let's keep time. Let's keep time. I always say that there are only 2 factors that make a human being or makes human beings to regret in life. There are only 2 reasons that make you either to miss a point or to get a point, or to make you enjoy life or to live a regrettable life. One of the factors is time. One of the factors is time. Then the second one is change. Those are the 2 things we have no control over them. Whether you want or not, time will go. Whether you want or not, you must experience a change in your life. But the question you must ask yourself, what kind of change do you want? Then the next question you must ask, how do you want to utilize your time? The little time that you have, how do you want to use it? Please, for me, I'm someone who is so conscious of time. Because I waited almost 20 minutes, we shall never recover that time until we die. That time will never be recovered. That time has gone. Okay? Members, let's keep time. Let's keep what?
Time.
Tomorrow we have lesson at 9. Are you aware? Sandra?
Yes, teacher.
Tomorrow we have lesson at 9. Okay?
Yes.
So what does it mean? Which means you must submit this work before tomorrow lesson. Okay? Yes.
Before sunset.
Before sunset. I think we have understood this concept, right?
Yes.
All right. And you have finished copying the question. Okay, you do it and then submit. Okay?
Yes.
But before you submit, mark it by yourself. Okay? How do you mark by yourself? Your instinct must tell you that answer is correct. Just remember what we have discussed. Is that how do you get maximum height? Or how do you get greatest height? How do you get the time of flight? How do you get the velocity? All those things, just check it within yourself before even submitting. Within yourself, you must be in position to check whether your answer is correct or wrong. Because that's what is the basic in A level. In A level, you mark yourself, members. Before you submit your work, just say that, this one I've failed, this one I've passed. Because you must know the principle. What is important, the principle and the concept. Now you have understood the principle. Are you able to apply the concept? Okay? Members?
Yes.
Nice lunch.
Likewise.
Nice lunch. See you tomorrow.
Okay.
Tomorrow, I want to see by 8:30, people are already joining the meeting. People are joining the lesson. By 8:30, people must be there already, waiting for me.
Okay.
Okay. A nice day if you must. Sandra, why are you laughing again? you tell Narubega to style up, okay?